Good afternoon, class. Good afternoon, Mrs. Thank you. You can sit down. Okay, I'd like to welcome you to this lesson, and especially for 2003. To those people who are also watching, welcome to the maths lessons for this year. Okay, today we are going to start off with something that you already should know from grade 10. We're just going to look at some definitions of, first of all, a number, and then the different types of numbers. And we'll also look at what to do when you are to add and subtract. I think today we'll start with fractions and not integers. Okay, I'm going to ask Jake, what is a number? Pass the mic.
A number is a measure of quantity.
Okay, number is a number is a measure of quantity. For instance, if I asked you how many fingers I put up, then it's 4, quantity of fingers. Okay, so a measure of quantity, that would be the most mathematical definition of a number. The other one is how many things, but how many things is to everyday language. Okay, mathematically a measure of quantity. Okay, next thing we are going to look at is the type of numbers. First one, does anyone know what a real number is? What is a real number? Megan?
A real number is the set of all rational and irrational numbers.
Okay, a real number is a set of, or real numbers is a set of all rational and irrational numbers. Okay, the simple way you would put it also is any number that you can put on a number line. So I'm going to write the definition down. Any number any number that can be put on a number line, or any number that can be written on a number line. And note, real numbers are actually all numbers. Okay, they are called real numbers because any number can be put on a number line, and you should know what a number line is. Okay, what is a rational number, Natasha?
A number that can be expressed as a fraction or ratio.
Okay, a number that can be expressed as a fraction. Danny. So is the number 2 a rational number according to that definition? You have to stand up.
Yes.
Yes. Why? Why is 2 a rational number? The answer is correct, yes?
Because it can be expressed as a fraction.
Okay. S. So 2 can be written as?
Fraction.
How?
By 2 over 1.
2 over 1. Very good. Okay. So any number that can be written as a fraction is called a rational number. Continuing from there, okay, a number that can be, I would write it also as this, a number that can be written in the form a over b. A over b is a fraction. Okay, and when that fraction is changed into a decimal, okay, when that fraction is changed into a decimal, that decimal will terminate, meaning it will stop, and it will also recur. Okay, those two are very important because it will differentiate between a rational number and an irrational number. Okay, so I'm just going to write that down. When written as a decimal, okay, maybe this word you should also write as changed. I think written is not a very good word. When changed as a decimal, it terminates, and I'll explain that, and it also recurs. Okay, for instance, if I changed 1/4, which is a rational number, to a fraction, to a decimal, it is 0.25. And 0.25 stops. I cannot continue. Okay, it's 0.25 full stop. Another number, 1/3 is a rational number because it is a fraction, 1/3. When I change it to a decimal, because I know this by heart, it's 0.33 recurring. Okay, did you get that? So an irrational number, if written as a decimal, or if it is changed to a decimal, it terminates and it also recurs. Or otherwise, there will be a pattern, like 0.252525. That fraction is also known as a rational number. Clear? Okay, now to the front. Desai. Pass the mic to the front. What do you think is an irrational number? Put your head up.
Numbers that cannot be expressed as a fraction or ratio.
Okay. Did you hear that? Again, or did you hear it? Okay. An irrational number, he said, is the opposite of that. A number that cannot be written as a fraction. Okay, I'll just put it this way. It's a number that cannot be written in the form a over b. And when I say a over b, I mean a fraction, provided b is not 0. B can be any number but 0. Okay. Any others? Looking at the definition of a rational number, can anyone also tell me how else I can define an irrational number? Anyone? Just by looking at this definition that I've written for a rational number. It should be the opposite. Okay, anyone? Now I'm giving you the freedom. You better use it. Lester. Okay, looking at this one, how can I write the definition of an irrational number?
The number doesn't terminate and it don't recur.
Okay, that an irrational number when written as a decimal will not terminate and it will not recur. Okay, so when, this is very important, when written as a decimal, okay, does not terminate and it also does not recur. Okay, I'll give you an example. Okay, maybe I'll write it here. Okay, the square root of 2, I used a calculator and I changed it to 1.4142135 and so on. The calculator cannot actually contain the number of digits that this number will take. And if you have a look at this 1.414, there is no pattern here, which means it does not recur and it will not stop. Okay, that is an example of an irrational number. Okay, it cannot be put in the form A over B, and when changed into a decimal, it does not stop, it does not terminate, and it also does not recur. Clear? Okay. Kila, what are natural numbers?
Natural numbers are any counting numbers excluding 0.
Okay, natural numbers are counting numbers including 0. So they are 0, 1, 2, 3, and so on. Oh, sorry, wrong. Excluding 0. My mistake. Okay, excluding 0. Okay, natural numbers are counting numbers excluding 0. 0 is not, does not have, the quantity does not exist, so you cannot include it in the natural numbers. Okay, I think it goes in the next one. So whole numbers will be numbers, the whole numbers including 0. Okay, they are counting numbers but including 0. So I'll just write down 0, 1, 2, 3, and so on. So these are counting numbers. Including 0. Esther, what are integers?
Integers are numbers, are positive and negative numbers that include the number 0.
In other words, positive and negative. If their numbers include 0, what do I write? Positive and negative whole numbers. Okay, for instance, -2, -1, 0, 1, 2, 3, and so on. Okay, I'd like you to remember this because there are lots of word problems that involve integers. You should know what they are. And I think it should not include R. I think it's only INTEGERS. All right, composite numbers. Rita, what are composite numbers?
A counting number larger than 1 and not a prime number.
Counting number
Larger, has a fraction
greater than 1,
and not a prime number.
not a prime number. Okay. Give me an example.
4.
4. Why is 4 a composite number? 1. Give me one reason.
It has multiple factors.
Which are?
2 times 2.
Okay, she says, you can sit down. Her definition, there were 2. 1, she said, a composite number is a number larger than 1 that Okay, it's a number that's bigger than 1 and doesn't, and it's not a prime number. That's what she said originally. Okay, it's a number that is larger than 1, but it's not a prime number. Okay, my next question. What is a prime number? Siegfried? Pastor Mike. Okay, we're going to define prime numbers first before we go back to composite numbers so that we know what Rita is talking about. Siegfried, what is a prime number?
A counting number that can only be divided by 1 and itself.
Okay, a counting number that can be divided by 1 and itself. Livingston, is 1 a prime number? No. Is 2 a prime number? Get the mic. Okay, my first question was, is 1 a prime number?
No.
No. Is 2 a prime number?
Yes.
Yes. What is the next prime number?
3.
3. Okay. So you all know what prime numbers are. 1 is not a prime number, but 2 is the only even number that is a prime number because it can only be divided by 1 and itself. Okay, then back to composite numbers. If Rita said a composite number is not a prime number, if that's the case, then what is a composite number? Daniel.
A number with factors other than itself and 1.
Very good. A number with factors other than itself and 1. So all numbers that are not prime numbers are composite numbers because they have, those numbers will have more than one factor or more factors than that particular number and 1. Okay, rectangular numbers. Pond relay.
Numbers that can be represented by dots arranged in a rectangle.
Okay, numbers that can be represented by dots arranged in a rectangle. Okay, for instance, 6. What about 4? Okay, 4 is a square number and not a rectangular number. Okay, next one can be okay, can that be a 3, 6, 9? Can 9 is a square number? Okay, the next one I think is 12. Okay, any number that can be represented by dots but then will be arranged in a rectangle are called rectangular numbers. So it's called a rectangular number. Okay, next one. What is a square number? Andrew.
A number that can be represented by dots arranged in a square.
Represented by dots. Is there any other definition, Peter? Or is that the only one? You have the same definition. Anyone who thinks there is another definition of a square number? Rita? Pass the mic.
A number that can be written as a product of two equal numbers.
Okay, a number that can be written as a product of two equal numbers, for instance, 1 times 1 and 2 times 2 and 3 times 3. Okay, it's also the other way you can write it also is the square of every number. Okay. Number 11, triangular numbers would be numbers that can be represented by dots arranged in a triangle. For instance, 3. Okay. 3, then 6. What's the next one? 10. Okay, we'll stop here. So it's 3, 6, and 10, and so on, but it will be numbers that can be represented by dots arranged in a triangle. Okay, we'll go on to the next thing. And I'll just go through this quickly, and then I'll give you your homework. Okay, operations with integers or directed numbers, as most teachers know them. The rule that we follow is BIDMAS. You know that from grade 10. B representing brackets, I representing indices, D division, M multiplication, A addition, and S subtraction. We know that if it is to do with division, multiplication, you can work from left to right, and also addition and subtraction, you don't have to add first and then subtract later. You can work from left to right. But you have to take note of the sign in front of the number. Okay, the first example that I have here, it's 4 minus 5 times 3 plus 2, because the rule says I have to multiply first. I multiply first, so 5 times 3 will be 15. So it will be 4 minus 15 plus 2. 4 minus 15 is negative 11. Negative 11 plus 2 is negative 9. Okay, number 2, I have to square 5 first, which is 25. Multiply 2 and 4, so minus 8, and then divide by 2. If I wanted to, I could have divided 4 by 2 first. 4 divided by 2 will give me 2. And then I multiply this negative 2 times 2. It's exactly the same. That's 4. Exactly the same as if I divided this negative 8 by 2. So it's 25 minus 4, which is 21. Okay, this one, it's brackets first. 6 minus 2 is 4. So 4 plus 4. And then multiply 9. I multiply first. 4 times 9 is 36. 4 plus 36 is 40. Okay, with fractions, the rule is you have to get the lowest common multiple first. Okay, a half plus 1/3. What's the lowest common multiple of 2 and 3? Agnes?
6.
Okay, what do we do with 6? Raylene?
Divided by 2 and multiplied by 1.
Okay, divide. Multiply by the numerator. Okay, 6 divided by 2 is 3 times 1 is 3. 6 divided by 3 is 2 times 1 is 2. The answer, 5 on 6. Okay, 1 and 1/4 plus 2 on 5. What's the first thing I should do? Velma?
Find the lowest common denominator,
Of which numbers?
4 and 5.
Do I have to add this one or
Yeah.
I change this one to a mixed fraction?
No, you add 1 and then you just change the fractions.
Okay, 1 plus. Is that what you are saying?
Yep.
Okay, lowest common multiple of 5 and 4?
20.
20 divided by 4?
5.
5 times 1?
5.
20 divided by 5?
4.
Times 2?
8.
8. Okay, so it's 1 and 13 over 20. Okay, that's on addition and subtraction of fractions. Next, multiplication and division. I've just written down either multiply numbers and then the denominators and then simplify, or you can cancel or you can simplify those with common factors. Or, sorry, that's when you multiply. When you divide, when dividing, you multiply by the reciprocal of the denominator. So, 3 on 4 times 4 on 5. I can either multiply and get 12 on 20 and then simplify and I get 3 on 5. Or otherwise, I can cancel 4 and 4 and the answer will still be 3 on 5. So long as you know that that's not 0, it's 1. Okay, 1 and 1/4 times 2 and 2/3. Change to a mixed fraction. 1 and 1/4 is the same as 5 on 4. 2 and 2/3 is the same as 8 on 3. And then you can cancel or you can multiply. 8 divided by 4 is 2. 5 times 2 is 10. 10 on 3, which is 3 and 1/3. Okay, 5 on 6 divided by 2 on 3. The second one here, you're dividing, so you have to multiply by the reciprocal of 2 on 3. So multiplied by 3 on 2. Okay, what's the answer? Someone work it out quickly and give us the answer. Put your hand up. Miriam? Pass the mic. Pass the mic.
One and 1/4.
1 and 1/4 or 5 on 4. Okay, I've got multiplication and division. 1 and 1/5 is the same as 6 on 5. Multiplied by 2 and 3/5 is the same as 13 on 5. And then divided by 4 on 5. Okay, if you follow this rule, we are going to get 6 on 5 multiplied by, I have to divide 13 on 5 by 4 on 5, so I have to multiply 13 on 5 by 5 on 4. So I get that, and then 6 times, sorry, I can cancel 4 and 6, that's 3 and 2. Okay, 13 times 3 is 39, 39 on 10. And that's the same as 3 and 9 on 10. Okay, your homework for tonight is on fractions. If you can have a look at your worksheet and circle the questions that are on the monitor. It's a with a pencil, please, because you are going to return the worksheets. It's not written as A, B, C, D on your worksheet. It's different numbers. So you have to look at the question and then circle it on your worksheet. It's worksheet number, I think it's page 3, where it says fractions. Okay, we have to let you go. You have to stand up and we say good afternoon before you go. So stand. Good afternoon, 11P. Thank you. We'll see you tomorrow.